A moving body's average speed during an interval of time is found by dividing the distance traveled by the time it took. This can be represented by the equation delta y over delta x, or change in y over change in x, which expanded is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Looking at the graph, we have 2 points at x sub 1 and x sub 2. These points are 1, 2, and they are 3, 4. So this would be our x sub 1, this would be our y sub 1, this would be our x sub 2, and this would be our y sub 2. So plugging this into our equation above, we would get 4 minus 1 over 3 minus 1 equals 3 over 2. So for this graph between these 2 points, this would be our average rate of change. This can also be represented by the equation f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, or f of x sub 1 plus h minus f of x sub 1 over h, where h equals delta x, which is x sub 2 minus x sub 1, and h does not equal 0. A line joining 2 points of a curve is secant to the curve. So the average rate of change for 2 points on a curve, x1 and x2, is equal to the secant line there, meaning it only goes over 2 points. So essentially, the secant line is the rate of change. To solve for the secant line, we can use the equation point slope form y equals mx plus b. Since we already know the rate of change, we can just plug in a point. Let's say 3, 4. So 4 equals 3 over 2, which is our rate of change, times 3 plus b. Then we can solve this algebraically. So 3 and 3 is 9. 9 over 2 is 4.5. 4 equals 4.5 plus b. So we will subtract 4.5 from both sides. So we would get minus 0.5 equals b. So that means our secant line would be y equals 3 over 2x minus 1/2.